Okay, let's take a look at an example where a salt, sodium iodide, is added to a solution. And that solution, and you can see there's a good reason that I teach chemistry and not art, but that solution has a mixture of lead and silver. And we're adding okay, both lead 2 iodide and silver iodide are slightly soluble salts. They are both slightly soluble salts. We can tell that by the given KSPs, which are 1.4 times 10 to the negative 8 and 8.3 times 10 to the negative 17th. As we slowly add the sodium iodide, the I minus concentration will increase. Now, these KSPs are equal to the expressions we could write would be the lead 2 concentration times the iodide concentration squared for the lead 2 iodide. And for the silver iodide, it would be the silver concentration times the iodide concentration. We can write that by knowing how to write those expressions, which has been covered earlier. So as this iodide increases, the Q will increase because Q has the same expression as the K, except it's not necessarily at equilibrium. So for the lead 2 iodide, the Q is going to be the lead concentration times the iodide concentration squared. And as this increases, my lead concentration, I know, my Q will increase. And when this Q reaches the value of the K, it will precipitate. It will precipitate the lead 2 iodide. Once we add just a tiny bit more iodide beyond that, which gives us this 1.4 times 10 to the negative 8 value, it will precipitate. So if we know our concentration of lead, which we know, and we know our K value, we can calculate the value of iodine that will make Q equal K and cause precipitation. And so in order to do that, we will just plug in the molarity for my lead. Then we can go through the algebra to solve. Oops, I didn't plug in the amount for the lead, so let's plug that in. That is 0. Okay, we can solve that for the iodide, and we find that 0.00017 molar, that is the minimum I minus to precipitate the lead to iodide. We can then do a similar concentration for the silver, a similar calculation. 8.3 times 10 to the negative 17th equals 0.0050 times I minus. Solving that for the I minus, we get 1.7 times 10 to the negative 14th molar is the minimum I minus concentration to precipitate silver iodide. So we're going to start slowly adding the sodium iodide. The iodide concentration will increase. It will increase to this molarity before it reaches this molarity. So this one is smaller. So that means the AgI, silver iodide, will precipitate first. And the concentration needed to precipitate it is going to be 1.7 times 10 to the negative 14th molar.